So let's continue with trig integrals. Suppose I have integral of tangent of x secant cubed of x dx. I'm going to go ahead and rewrite that as tangent of x secant of x secant squared of x dx. And I hope you agree that I didn't break any rules, I didn't change anything. If I let u equal, let's see, secant of x, that would be a better choice because du now equals secant x tangent x dx. And that's what I have in here, secant x tangent x dx. So I can replace that. Let me actually go ahead and show every step there is. So the baby step after this is to solve for dx and say that dx equal du over secant x tangent x. So now here I'm going to rewrite this. So this equals, let me go ahead and put the equal sign here. Tangent of x, secant of x. We said u equals secant of x, so u to the second. And I can replace dx with du over secant x tangent x. So once again, I'm showing every step there is. This equals integral of u to the second du, and that equals 1/3 u to the third plus some constant c. And remember that u equals secant of x, so that equals 1/3 secant cubed of x plus some constant c. Okay, let's try another one. Let's do a longer one. How about integral from 0 to pi over 4 secant to the 6th power of theta tangent to the 6th power of theta d theta. So notice that I have both of them are the power of, the same power. So I'm not, looking at this, I'm thinking that I would like my u to be tangent. Why is that? Because if I let me just, you see, if I let u equal tangent of theta, then I know that du equals secant squared of theta d theta, and that's very helpful. So what I'm going to do, I'm going to just in here say this equals from, let me change actually color, from 0 to pi over 4. Notice that the derivative is secant squared. So I'm going to go ahead and put the tangent to the 6th power of theta here and write this as secant to the 4th power of theta, secant squared of theta. And notice that here, let me just continue this here. I can claim that d theta equals du over secant squared of theta. Once again, for my videos, I like to show every step there is. So instead of d theta, I write du over secant squared of theta, and I can cancel this. Okay. So now what to do? Now I have tangent to the 6th power, and I have secant to the 4th power. And also one thing I shouldn't forget that I have I have boundaries here. I'm going from 0 to pi over 4. So in fact, when I, right now this is x equals pi over 4 and x equals 0. So I need to change that to u. Let me continue that. And let me just put this a little bit farther here. When x equals 0, tangent of 0 is 0, so u equals 0. When x equals pi over 4, when x equals pi over 4, tangent of pi over 4, which is sine of pi over 4 over cosine of pi over 4 is 1. So u equals 1. So now I can rewrite this in terms of u, not anymore x. So I'm going to go from 0 to 1. Okay. And notice that we said that u equals tangent of theta. So this, I'm going to write it as u to the 6th power. But secant to the 4th, I need it in, in terms of tangent. I know, 1 plus tangent squared is secant squared. So I'm going to write this as 1 plus tangent squared of theta quantity squared. Okay, so now d theta. Now that and actually I changed this to du. So therefore, now I can rewrite this tangent in terms of u. Once again, I'm showing every step there is. So from 0 to 1, u to the power of 6, 1 plus u to the 2nd, and I do have to the 2nd here, du. I hope you can see this. This has a little bit of more, a few more steps than the previous ones. Okay, looks good. So first, let me expand this. Going to the next page, I'm going to have this sequence from 0 to 1. I had a u to the 6th, but then I had 1 plus u squared, quantity squared becomes u to the 4th plus 2u squared plus 1, expanding that, du. Now I'm going to go ahead and multiply the u to the 6th through, distribute that. So I have from 0 to 1, u to the 10 plus 2u to the 8 plus u to the 6, all that du. Now we are ready to take the integral. So this sequence, u to the 11 times 1 over 11 plus u to the 9, so 2 over 9 plus u to the 7, and so I get a 1 over 7 in here from 0 to 1. Not bad, so 1 is easy to, when I plug in 1, I will get 1 over 11 plus 2 over 9 plus 1 over 7 minus everything else is going to give me a 0. So minus 0. So for this, I'm going to have to use a calculator. 1 over 11 plus 2 over 9 plus 1 over 7. Okay, so my calculator is telling me it is equal to 316 divided by 693. 316 over 693. 1 over 11 plus 2 over 9 plus 1 over 7. Okay, and that makes sense though, because 7 times 11 is 99. 7 times 11 is 77, times 9 times 10 would give me 770 minus 99. Yep, 693. Okay. I think that's enough for this video. Thanks.